Greetings and welcome to episode 17 of the Sustaining the Herd podcast, brought to you by Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle, and I'm joined by my co-host, Brock Vitek. Today, also, we're joined by our special guest, Jim Wallace of BioFiltro. And before we learn more about Jim and BioFiltro, just a little bit more about our Sustaining the Herd podcast for our new listeners. And thank you to our return listeners as well. So what does sustainability mean in the world of Agri-Services and engineering? Well, it's a number of things. We can have environmental sustainability, that is taking care of our food and or taking care of our air and our water. Sustainability could mean utilizing our resources the best that we can. And it can mean financial sustainability, in that we have to have enterprises that are profitable and able to continue operating. So whether you are from the production agriculture world, or if you're from the support industries that support animal agriculture, or just as we like to say, the people in town, people who don't have any real affiliation with production agriculture, but yet do eat. We're grateful for you all to be here, and we hope that you can come away with something. Again, our guest today is Jim Wallace of BioFiltro, and disclaimer that Jim and I go way back, and we've worked together at many projects, and I've worked for Jim, Jim's worked for me, and it's always been really, really good. But Jim is with BioFiltro, and people in agriculture, generally, we don't like to talk about ourselves and talk about our successes, and we're kind of behind the scenes doing our thing. But I know you, Jim, and so if you don't kind of tell us everything, all the good stuff that you do, I will make sure that everybody knows about it, and I mean that in a very positive sense. So with that, our guest today is Jim Wallace. Jim, please tell us about you.
Thank you very much for that warm welcome, Andrew. I appreciate that. Good to see you, both you and Brock. Again, pleasure to join you today. And as Andrew said, we've had a great collaboration through many, many years, even sharing the same major professor for our graduate work. In terms of background, I'm an engineer. I started out my career in the industrial wastewater world before transitioning to dairy about 22 years ago. During my time in dairy, I've always been in and around the development and or the advancement of manure-oriented technology, primarily around anaerobic digestion and nutrient recovery. During this 22 years in dairy, I've worked independently. I've worked for a technology manufacturer. I've worked within the dairy industry for both Nutrient and Dairy Management, Inc., as well as a digester developer. And as Andrew said, I'm now with BioFiltro, where I lead our engineering and technology efforts. So again, it's a real pleasure to be here and to talk with you a little bit about BioFiltro and manure management in general.
And just something, I'll kind of highlight in terms of your background, Jim, that I've always found to be very unique, is that these animal facilities, animal production, and manure management, it's gotten more and more complicated, to where we're not just taking the manure and we're going out and spreading it day in and day out. And so I think one of the strengths that you have always brought and will continue to bring is that industrial background. It's the different perspectives of manure treatment that I think really comes into play today. And so that's great.
Wonderful. Thank you for that. Yeah, appreciate that.
Jim, thanks again for being here today. I appreciate your great introduction. And as you shared, you have a lot of experience. I know Andrew just highlighted some of that. So I'd like to ask you, what are the biggest challenges facing animal ag with respect to manure and the environment today?
Yeah, no, great question. I'm going to put one caveat out there, and that caveat is that my experience is almost exclusively dairy related. However, I think it is fair to say that the same challenges that dairy faces apply across all of the animal ag sectors. So with respect to the challenges, there are really two that bubble to the top of my list. The first is, I think, really the most obvious, and that's just the straight up management of nutrients and water. With the consolidation of animal ag over the last 40 years, there's more manure to manage at the farm level. There are larger storages, and there are simply bigger challenges with timing of application. And this is where technology is really stepping in to offer better options and alternatives for more efficient nutrient and water management. The second challenge, I guess, that I see is that of GHG reduction. And again, I can't speak for the other sectors. However, within dairy, we have a stated goal of achieving greenhouse gas neutrality by 2050. And to try to put a little context around what GHG means at the dairy level, I think we have to talk about the four primary contributors to the farm's GHG footprint. And they are enteric methane, feed production, the energy that's used to run the dairy farm, and manure. And depending on the region, manure ranges between about 1/3 to more than 50% of the farm's GHG footprint. So it's the most significant area, the biggest opportunity area for impacting that 2050 goal that I highlighted just a moment ago, that being achieving greenhouse gas neutrality by 2050. So those two are the two that I see as being sort of the most prescient, biggest challenges that the industry faces currently with respect to manure in the environment.
That's great. Yeah, and I completely agree with you, especially on that greenhouse gas reduction or neutrality point, because we see it everywhere, especially working in ag. But I know the beef cattle industry, for example, has set a goal of, I believe it's climate neutrality, similar metric, I might say, by 2040. So something similar, and we're just seeing it, coming down from investors and consumers through the food companies and the CPGs coming down the line. This whole sustainability thing doesn't appear to be a flash in the pan from every observation that I can make. And greenhouse gas reduction is certainly one that is in the spotlight right now, and it's a big challenge. And I'd like to think that our biggest challenges are also our biggest opportunities. And I know that opportunity can come in many forms.
I love that, Brock. I think that's very well said.
So, Jim, if you kind of frame the challenges as maybe I'm summarizing them a bit as the nutrient side, challenges with nutrients, and then we have challenges on the GHG side. So, kind of, in your introduction, of course, we talked about how you've worked with so many technologies. So, can you kind of just go through the things that you see, that you've experienced and worked with, that really have the most potential for, and feel free to even mention what you think has the industry has done that doesn't lack potential, and so kind of, if you could just kind of give a bit of a survey of the technology, and what do you see has a heartbeat?
Yeah. So I have had the opportunity to, in a firsthand way, touch a lot of different technology. And those that I haven't had the chance to touch firsthand, I've also had the opportunity to evaluate when I was with Nutrient. So I've kind of been in and around a lot of them. And to your point, Andrew, there are some really, I think, straightforward, simple methods that are tried and true. And I'll talk a little bit about those in terms of both nutrient management and GHG reduction. Oftentimes, they're very closely aligned. And there are certainly those technologies that have come along. They've been intriguing and interesting, but oftentimes they haven't necessarily sort of passed that litmus test of being both workable and cost effective at the dairy scale. And that's always a challenge that we face. But let me start with sort of the tried and true technology from a GHG reduction standpoint, that being anaerobic digestion. It's certainly the best known technology that's applied in the animal in the animal ag space. It's widely adopted. It's a proven GHG reduction strategy. It has clear economic outcomes in terms of energy production, and though by itself anaerobic digestion does not impact the water and the nutrient status of the manure, it does set the stage for improved downstream treatment. So it's a really great GHG reduction strategy, and it's a great sort of setting the stage for what comes next in terms of nutrient management. So that kind of takes us to the nutrient management side of technology. In general, most nutrients follow the solids fraction in the manure stream. So technology that targets solids are, as a general rule, very effective at nutrient removal. And at the same time, if you're taking out solids, you're taking out the volatile fraction, that being the methane generating fraction. So nutrient removal technologies have the added benefit of not only improving the farm's nutrient status, but also, as a result of removing volatile solids, improving the farm's GHG status. So for simplicity in our discussion, I'm just going to kind of group these basic technologies into mechanical solid separation, chemical separation, and then the more advanced technologies that we see being applied at the dairy scale. So there are myriad mechanical separation technologies that are deployed at the farm scale, from simple screening that's widely used, slope screens, rotary drums, screw presses, all the way to more sophisticated centrifugation type systems that are focused on removing suspended solids from the manure stream. Then we kind of move to the next level, that being chemical flocculation, technologies that are targeting a finer and finer fraction of the solids, leading to better nutrient separation outcomes, better water quality outcomes, but also at higher capital in operating costs. So these are technologies, as I mentioned, like chemical flocculation, that integrates things like dissolved air flotation along with chemical flocculation to separate those finer solids and produce cleaner water.
Hey, Jim, if you don't mind, let me just interrupt you for a second.
No,
and
by
this
all
is just
means.
something to point out, and maybe something to discuss. I think you raise a good point that the nutrients tend to follow the solids,
Yeah.
and as you went through your methods of solid separation, I think just to see if we concur that just your typical solid separation alone doesn't get the job done, because slope screens, rotary drums, et cetera, it's really getting out the large fibers. It's not until you start getting these higher levels of capturing solids that you get the nutrients.
Well, I would say that you're in the 10 to 20% removal range with coarse fiber separation,
Right.
screens, et cetera. So agreed that if your goal is a high level of nutrient separation, then screening is a first step in a more
Right.
advanced system. So it's sort of like, and
Yeah.
maybe that's the way to frame that being that nutrient or that coarse fiber separation, the idea of using screens is a first step in a more advanced process, let's say, of nutrient removal. So it has minimal impact on solids removal. It does have some, but it also sets the stage for things like chemical separation and chemical flocculation, and then some of these other advanced technologies. All of those technologies have in common the fact that they use coarse fiber separation at the front of the process, that initial step.
Yeah, and I just wanted to make a clarification, only because I just wanted people to get the
Yep.
gist for the fact that it's not a matter of, hey, we're doing a screw press, we're doing a rotary drum, we've got all our nutrients. It's just, as you said, it sets the stage for that next level of solids
Yeah,
recovery.
no doubt about it. No doubt about it. So I'm going to pick up with sort of the next level of treatment, and I think of this as more in the line of chemical flocculation, where we're targeting finer and finer solids, leading to better outcomes, but at higher capital and operating costs. A typical pairing of technologies in this area would be chemical flocculation, so addition of chemicals to create a flock, coupled with dissolved air flotation to separate those solids from the cleaner water. Again, that solid fraction tends to be a much more advanced, higher level of treatment than the mechanical separation that I previously described. And then the sort of next level of treatment, I consider these to be the advanced level technologies. There are technologies like membrane-based systems where ultrafiltration could be deployed in combination with, let's say, reverse osmosis to produce concentrated nutrients in much smaller volumes and clean water that in some cases could be suitable for discharge. There are other really interesting technologies that, again, fall into this advanced treatment scenario, evaporation technologies. And in this case, I'm really referring to one in particular. It's manufactured by Cedron. It's their VarCore system that produces cleaner water. It produces a stable nitrogen-based liquid, and the balance of the organic nitrogen and phosphorus are captured in a dry solids fraction. So it's a really interesting next level technology. There are a couple instances where this is currently under construction. It's going to be fascinating to see how this plays out. But it's largely a technology that only makes sense at very large scale farm operations at this time. And then lastly, there's a really fascinating technology called vermifiltration. It's pioneered by a Chilean company called BioFiltro. There's now a North American variant of that company based out of Davis, California. And as I mentioned, I do work for BioFiltro at the present time.
Very good. So, Jim, how about we jump into vermifiltration? I'd like to ask, what is vermiculture or vermifiltration, and how is it different than all of these other technologies you've mentioned, and what are some of the benefits of it?
Absolutely. I'd love to talk about it. The vermifiltration process, which I'm going to describe in more detail in a minute, is really the heart and soul of the system. However, we take a systems-based approach to the design, and we wrap other technologies around the vermifilter to provide a complete wastewater solution for the farm. Specifically regarding BioFiltro's technology, the vermifiltration system processes wastewater through a filter of biomass, earthworms, microbes, and all of that's sort of underpinned by drainage cells to collect the treated water. The process removes up to 90% of the contaminants within approximately 4 hours. In general, water is irrigated onto a bed of wood chips containing worms. The irrigation system is a traditional linear pivot that walks the length of the beds. Just to kind of give our audience a sense, a bed could be, in general, 60 feet wide. It could be 1,000 feet long. It could be longer than that. And there could be 2, 3, 4, 5, 6 beds that comprise a system at a given installation. The worms consume a portion of the organic matter, but their primary contribution to the process is to provide continuous movement and wormholes, if you will, that allow the beds to remain largely in the aerobic state. As water filters through the bed, organic matter is degraded and nutrients are captured by the filter. In a high solids environment, like what we see in the livestock sector, the beds do become matted with manure residue and solids as water is sprayed on the beds, and they're tilled on a regular basis to refresh the surface. Then, after about 18 months, maybe 2 years, the beds are harvested. So we actually physically go in and we remove all of the bedding material, the wood chips and the worms and all the organic matter and the captured nutrients. And that product is then sold as a vermifilter product. It could be processed into higher value products. For example, the worm castings can be separated and sold. That product could be further composted into other higher value end products that can then be exported off the dairy.
Excellent. Jim, could you give us a sense for how how vermifiltration has an impact on both nutrient management and GHG emissions potentially at the same time? Just to you briefly give us a sense for that.
So yes, great question. Um, the vermifilter is really that ideal combination of technologies in the sense that we are actively targeting water quality. As water flows through the filter, we are adsorbing organic nitrogen and phosphorus and capturing high percentages, 60, 70, 80% of those nutrient constituents. We are also seeing mineralization of nitrogen, and then both nitrification and denitrification is occurring in the bed. In addition, volatile solids are retained by the bed. Some are degraded, some remain, but the net effect is that by removing those volatile solids from the water, retaining it in the bed, we are effectively eliminating any downstream methane generation in storage that would otherwise occur in a long-term liquid storage at a dairy farm. And that's one of the really critical key benefits to the BioFiltro process.
So, Jim, as for the BioFiltro system, when we talk about vermiculture, can we just say more or less that's like worm farming? Is that okay
perfect.
to say?
Vermi means worm, and filter means,
okay.
Obviously filtration. And what we're putting together is this combination of worms and a filter, and the worms are part of that filtration process. So worm farming, perfect.
Yeah. Okay. So basically, we're creating this bed that's amenable for the worms to grow, and we're feeding it, we're watering it, and they're just doing their thing.
Right on.
Right. And so back to the system. So we'll talk dairy, of course. So is simply sloped screen effluent level solids recovery acceptable to go for the liquids then to go onto the bed?
So that's always our first step. So our first step is going to be some level of screening, and that's part of this systems-based approach that we take. The better we do in terms of suspended solids removal before we reach the beds, the more efficient the bed can be at addressing the balance of the, let's say, more the smaller particle volatile solids and the dissolved volatile solids, as well as the nutrient management side. So that kind of holistic approach to system design is predicated on efficient pretreatment. It always, to your point, starts with some level of screening. We then will often use gravity separation as a next step, and then from there we'll go into the vermifilter.
Okay. All right, that makes sense. And then, so we're collecting what essentially leaches through the bed, and would that just then go on to a manure storage pond?
So, and this is where I think that there's a degree of complexity in terms of describing this, but let me give it a try. What we do with, let's say, a flush dairy operation, where there's a large volume of flow that's making its way to the manure management side of the farm, where historically there may be multiple lagoons in series, and then let's say the final lagoon represents the cleanest water, and that's then returned to the farm for flushing, and the process starts again. What we seek to do is we seek to create a closed loop system such that water is used to flush. It then, in its entirety, passes through a screening process, through gravity separation, and then what constitutes the new manure, the excreted manure plus the fresh water added to the system, that flows forward to the beta system. All the rest of that solid separated water and gravity separated water that's now consistently clean, consistent in terms of its sort of year-round status, goes back for flushing. So what we offer to the farm through this holistic systems-based approach is consistent flush water year-round and treatment of the volume of manure that's generated on a daily basis. That's what is applied to the vermiculture, percolates through the bed. The water that's collected at the bottom of the bed then is that clean water that then goes to the long-term storage and is used for land irrigation under most scenarios.
Right. Okay. So really, these would be set up very similar to like an AD system where you would be recycling the water before the treatment process, as not to add the loading onto the treatment process.
Precisely.
Yeah. Okay. So getting a handle on this, and then so once these beds they reach their life with whatever, I believe you said 2 years, could be as long as 2 years.
18 months, could be as long as 3 years. It really is all about the solids loading that the beds are seeing. Yes.
Okay. And then is that, as far as the cleaning of the beds, well, at that point, those beds, in terms of the nutrient content, particularly the phosphorus, I would think is very, very high, right? Because you're really concentrating a lot of nutrients. And
that's right.
And then is that something that the dairy can they clean these beds? Is it something they bring equipment in and scrape up the manure, or is that something that is part of the BioFiltro offering?
Oh, I'm so glad you asked that question. Our approach to the dairy-based systems, the farm-based systems, is that we are bringing the technology to the dairy, and we are then operating those systems. The dairy has a role clearly to play as a partner in the system, and we work in a collaborative fashion with the dairy. But we are bringing the operational expertise and management of those beds long term, so that the dairy doesn't have to focus on that end of the treatment system. We address that. We take care of it. All elements of that are within the general scope of BioFiltro. So long-term management, bed replacement, sale of the Verma product, those are all elements of the program that we bring to the farmer as a value add benefit.
Gotcha. And then ultimately, what could be some of the obstacles to adoption for the vermiculture, the vermifilter technology?
Great question. And you and I both know well, Andrew, that most technologies that can be applied, whether they're about nutrient recovery or whether they're about GHG reduction, like anaerobic digestion, most require very large dairy operations in order to make economic sense. One of the things that I think is really extraordinary about biofiltration, the BioFiltro process, is that it is extremely scalable and it can fit on many, many farm sizes and farm configurations.
Jim, as for just other potential obstacles, I think about worms and frozen ground and whatnot. Is this technology at all geography limited?
It's not geography limited. However, having said that, one of the major challenges with this type of a process is not unlike the very same types of challenges that any dairy farm faces that's operating in a cold climate. If you're pumping water through pipes and allowing it to irrigate over the top of beds in freezing conditions, you are going to have challenges where things freeze up. Again, similar to sort of the realities that we face on dairy operations in the upper Midwest and the Northeast. So we're certainly not immune to those very same challenges that the dairies fight through on a year in and year out basis. However, what we can do with this type of a process is we can effectively shut it down. The worms are fine. The worms are going to be able to go deeper into the beds. There's no issue from a worm standpoint or a worm health standpoint. It's more about the water and how you move water in freezing conditions. So what we like to do is we like to hold water during the very cold months where freezing conditions could prevail, and then make up that volume of water that was stored once temperatures are warm enough to resume normal operation. And by normal, I mean being able to pump water because temperatures are above freezing.
Gotcha.
And let me also say, Andrew, from a GHG standpoint, very little generation is going to occur during freezing conditions. It's, methane generation is a biological process. All biological processes slow down, nearly stop under freezing conditions. So as a result, even if we do hold water for, let's say, a month during very cold temperatures and then process that water when temperatures warm up, we've had almost no negative impact from a GHG standpoint.
Jim, you've described briefly some of the physical products that come out of this system, but I was wondering if you could just recap what all the physical products are coming out of here, as well as what I might label as the environmental products or environmental attributes that come along with it, and what just simply speaking, what the value of some of this might be, even if that doesn't mean putting a dollar amount on it.
Coming back to the products, there are 3 products produced from the BioFiltro process: cleaner water, a verma product, and there are environmental attributes. And those environmental attributes specifically are carbon reductions. And let me just make a couple comments about each one of these 3 products. From a cleaner water perspective, that really is about clean water for irrigation with a substantially reduced nutrient loading, allowing for a much greater degree of flexibility for the dairy farm to time their applications, to gain benefit from the water value, and to avoid some of the negative implications of applying water that has a high solids content. So that cleaner water is a big deal from the irrigation standpoint. Also, our process results in cleaner, fresher, and consistent flush water. So in general, for the dairy, that cleaner water piece is a really big deal. On the verma product side, when a bed reaches its useful life, what remains are the nutrients that have been filtered. There's worms, there are worm castings. All of that has value, and it can be, in a best case scenario, exported off farm for higher value. Additional products could be created from that verma product. As an example, the worm castings could be separated out, and those could be sold at a much higher value. And then finally, the environmental attributes. What we're producing from this process is a reduction in the GHG potential of dairy manure. Effectively, what the process does is it removes volatile solids that would otherwise create methane downstream. So what we're able to produce are carbon credits that are built around avoidance credits. And I'll make the distinction here between this and anaerobic digestion. Credits generated from anaerobic digestion result from creating methane. So the goal of anaerobic digestion is to create as much methane as possible and then to use that methane in a positive way. What we do with the BioFiltro process is we actually avoid ever making methane. That's the avoidance credit element of this, and we consider that to be a very high value credit.
That's very interesting how digestion and this are just really opposite in terms of the mechanism behind how that carbon credit that's sold for revenue is created. Very interesting.
So, Jim, it's really interesting because, it sounds like most of the nutrients, or a large portion of the nutrients, are captured in the bed, and the water that's being discharged is much lower in nutrient content. There's no methane production, and so are there any other technologies that would be paired with this, or is this pretty much standalone? Of course, standalone after solid separation, settling, etc.
Well, you make a great point in terms of the other technologies, and yes, to the point that you just made, we do pair this always with pretreatment. So it's always going to be paired with a coarse fiber separation, solid separation technique to limit the loading of suspended solids to the bed. However, we are also actively designing 2 projects right now that are funded through California's Dairy Plus and Dairy Digester Research and Development Program that will follow digester systems. So they're lagoon-based ambient temperature systems that will flow from the digester to the vermifiltration beds. So I think that's a great example of pairing digestion with vermifiltration to generate the benefit of both GHG reduction on the front end with the digester, additional GHG reduction on the back end with the residual VS that isn't digested through the vermifiltration process, and to address the nutrient side of the equation and produce cleaner water for land irrigation at the end of the process.
So, Jim, it's amazing how clean, and I say clean, I'm making clean in air quotes, the discharge water is that comes off the beds. And what I would encourage all of our listeners to do is to go onto the BioFiltro website and under projects, click on the Royal Farms project link, and you will see where BioFiltro staff are wakeboarding on a manure storage pond. And so if there's any question in terms of what level of treatment is being achieved, there you go. You can see it for yourselves. Well, Jim, this has been really interesting. Our listeners, I believe, and Brock and I, we've learned a ton about vermiculture and vermifiltration. Anything we haven't covered that you'd really like to explain about the process, et cetera?
Yes, Andrew, there is one topic I'd like to make sure I share with your listeners. And I want to come back to the GHG implications I described under the challenges portion of the conversation. I've never met a dairy farmer that didn't want to adopt technology that improves their environmental standing. However, dairy farmers are price takers, not makers. What's really cool about this technology and BioFiltro is that we go out and we find downstream credit buyers, so dairy supply companies who have made sustainability commitments to their shareholders to reduce their carbon footprint, and they want to keep those commitments within their supply chain. These companies then invest in the carbon reductions that we've talked about, and then we're able to provide these systems to most farmers at no cost to the farm. So I want to highlight that because I think that's such an exciting innovation in the world of both nutrient management and GHG reduction technologies.
That's certainly not the standard when it comes to environmental technologies, and sounds like it really can help BioFiltro stand out in the marketplace as farmers are looking at opportunities and options that they have. Very good. And finally, my last question for you, Jim. This has been a fun episode, a really interesting topic. And I imagine that some of our listeners would enjoy reaching out to you and your team at BioFiltro if they have any questions and would like to learn more. So if they would like to reach out, how can they do that?
Brock, let me first say thank you to you and Andrew. I've really enjoyed it as well. Thank you for the time and the opportunity. For those listeners that would like to learn more about BioFiltro and vermifiltration, please feel free to go to our website, www.biofiltro.com, and go to the contact tab, and we will get back to you via that route. Or you can also feel free to reach out to me directly at jwallace@biofiltro.com. I'd love to talk with you and share more about what we're doing. And again, thank you, Andrew and Brock. I've really enjoyed it.
Outstanding. Thank you as well, Jim. We've really enjoyed this. And for all of our listeners, thank you so much, both new listeners and returning listeners, for choosing to spend some time with us once again, as some of you regularly do. We've enjoyed having Jim on, and Andrew and I look forward to being back with you again in a couple of weeks with a special episode. And I'll give you a bit of a teaser for that. Our episode will focus on a year in review or a recap of season 1. Since this has been our first season of Sustaining the Herd, we started back in April, And then the episode in 2 weeks will be the final one of this calendar year before Christmas. And then we'll be back with you again in January. So please come back for a great year in review in a couple of weeks. Until next time, thanks for joining the herd today.